2 says the graph of y equals f of x is shown. Sketch the graph of f negative 1x. What is just f negative 1x? Fancy way of saying what? What is this just asking you to find? Inverse. And what does inverse just mean? What is like layman's terms of inverse? Yeah. X and Y switch. That's it. If you remember that, not a hard concept. X and Y switch. X and Y switch. So I know I'm moving a graph. A graph has more than one point. It has a few points. If I'm moving points, I'm going to use mapping. So I go X, Y becomes Y, X. You try and sketch the new ones. So the more coordinates you pick, the more accurate it can be, right? But this one only has 2 arms and a vertex. So you really could pick 3 and get away with it, right? So that's what I'm going to do. So I'm going to, I know this isn't perfect, but I'm going to pretend it's going through there. So negative 4, 0 is going to become 0, negative 4. And then negative 1, 4 is going to become 4, negative 1. And then positive 1, 0 is going to become 0, 1. Is the inverse a function? No, it wouldn't pass the vertical line test. The vertical line test is for every x, there's only one y. So you draw vertical lines to see if it crosses through more than once. If it crosses through more than once, it's not a function. Is the original a function? Would the original pass the vertical line test? So if I drew a line here and here and here and here and here and here, would it pass it? Yes. So the original passes the vertical line test. True statement. But you all agreed that the inverse does not. It fails it. Correct? It doesn't say this on here, but we're going to practice with every graph anyways, just to get used to it. The curriculum states, and we're paying real close attention here, the curriculum states that I have to teach you how to restrict the domain of the original. We restrict the domain of the graph I give you, so that when I redraw it, it passes. Okay? We are not restricting anything of the inverse graph. We're not doing any of that. We're restricting what's in front of your face. How can I restrict the domain of this? How can I cut some stuff off so that when I redraw it, it passes the vertical line test? It only goes through once. That's what the curriculum is. It's like, how can I take this graph in front of me, cut something off of it by restricting the domain? Restricting the domain means only keeping part of the graph, so that when I redraw it, it passes. Okay? That's the outcome. So, when I look at this one, I say, well, the issue lies that I have 2 arms here. With the 2 arms, I draw a vertical line, it drowns, correct? Now, this is also the thing. Do I have to draw the inverse to find out if it doesn't pass? No. Because if I test the original with vertical lines, I'm testing if the original passes, correct? If I actually test the original with horizontal lines, I'm actually checking for vertical lines on the inverse. Because remember, you're taking all your x's and you're converting them to y's, and all your y's, you're converting them to x's. So a vertical line on my inverse would actually be a horizontal line on my original. So to check if an inverse actually passes the vertical line test, I don't have to redraw it. I don't have to find the inverse. I can check the original with a horizontal line. If the original doesn't pass a horizontal line test, then the inverse won't pass the vertical. Does that make sense? So we're going to write that. Horizontal line test on the original checks if the inverse will pass the vertical line test. And be a function. Do not erase yours. I'm proving a point. Okay? Don't erase yours. All right. So, I don't draw the inverse at all, correct? But I want to know if the inverse is a function. So I test the original with a horizontal line test, correct? So I go poof. And I say, fails, correct? So the original, if I want to check if the original is a function, I do vertical lines. Boom, 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 boom. The original is a function. Check for a horizontal line on the original, then the vertical line is going to fail. Poof, out, correct? So I say to myself, this doesn't work because I have two arms. We agree? But if I kick off one of the arms or I kick off the other arm, it'll pass. Yes? So say I got rid of this one. I'm like, go away. I don't want you here. Get out of my life. Okay? I go to the vertex and I say, okay, well, this one starts where? At what x? Because we're restricting domains. We're restricting domains of originals. This one starts where? -1. We agree? So if I say, okay, I'm going to restrict my domain. To x such that x is greater than or equal to -1, xer, then that's an r, sorry. Then I throw a horizontal line test in there. Does it pass if that arm's gone? Yeah, you'd have to visualize that the squiggled arm is not there, right? So it would pass. So most people can do that. What most people fail at is drawing the restricted arm because they don't actually know which one exists. So they like sketch the whole thing and erase one of them and hope for the best. No. Take the arm you have left, correct? Take the coordinates off it and do what with them? What do you do with your coordinates? Just flip them, redraw it. That's it. Don't overthink the process. Okay? This is the arm I have left. I take these coordinates and I flip them and redraw it. Okay, this one's at -1 and 4. So I go to 4 and -1. Boom, here it is. This one is at 0, 2. I go to 2, 0. Boom, here it is. This one's at 1, 0. I go to 0, 1. Boom, here it is. There's my inverse. Don't overthink it. Just take the coordinates off of your original. Trace those off. And flip them, redraw it. That's it. Now, how do I know I'm right? If I throw the identity line on there, which is 0, 0, 1, 1, 2, 2. Where's the invariant? On the identity line. I know I'm right. The invariant stayed. Remember, the invariant happens on the identity line because that's when x and y's are the same. And that looks like approximately 0.6 and 0.6, or 0.62 and 0.62. Like, I don't know what it is. They're not going to ask you what is the invariant point when it's not a nice one. But they'll ask how many invariant points. One. It happens on the identity line. Okay? Questions that can come up. Ready? Boom, boom. Boom. How many of those graphs will their inverse be a function? How many of those graphs will your inverse be a function? When I get this, some people take 10 minutes to do this question because they redraw every single one of them. Or they'll say, but Mrs. Lepp, there's no scale. I don't even know what the coordinates are. I'm going to guess, and then they just sketch it. Do we have to do any of that? Do we need to redraw it? What do we just need to run on each of these? Horizontal line test to check if the inverse is a function. Vertical line test to check if the original is a function, right? So is this one an actual function? I'm talking about originals now. Is this first one a function? Yeah. Is the second one a function? Yeah. Third one? Yeah. Fourth one? Yeah. These are all functions. The originals are all functions. Are there inverses functions? Is this one a function? If I draw horizontal lines, it immediately fails, actually. I don't have to draw more than one. Failed. So the inverse isn't a function, correct? What about this one? Is the second one inverse a function? No matter how many horizontal lines I draw, it passes, correct? So the inverse is a function. What about this one? Look, it passes. It passes. Ah, the inverse is a function. Is that true? Is the inverse a function? Did I check everywhere? What about here? Fails. It crosses in a whole bunch of spots. It's a horizontal line. So this inverse is not a function. And then this one? Ah, it passes. We're good. It's not the goal to find where it passes. It's the goal to find out if it doesn't pass somewhere. And right away, fails miserably. Correct? So does that make sense to you? It may pass in spots. Don't really care. The moment it fails, it's done. It's not a function. Make sense? Now, if I ask you for how many invariant points there are, I would actually have to give you scales. But invariant points, you would just do this. You draw your line. 1, and then this is going to eventually cross, so 2. Right? You just thought to draw the line y equals x on it. And wherever it crosses through, invariant points. Like if I drew this one, the line y equals x, let's pretend that the scale actually makes it look like this. This one would have 1, 2, 3, 4. That's why I have to give you a scale, because you have to be able to draw the lines appropriately, right? Like this could be negative 100 to 100, and then what's the scale, right? So I have to actually give you a graph with Cartesian plate spots and give you what it is. Okay. We're actually flipping past that one, and we're going to this one. So this is more so of a question you could get on the test. Okay? You can get those other ones where you sketch them. This is more so like a written response type. So here it wants the equation of a reflection in the line y equals x. What is that a fancy way of asking for again? Yeah. The inverse, which means we flip the x's and y's. That's it. Ask you the equation of the inverse. Remember, it can ask you this. It can ask for inverse. It can ask for y equals f negative 1x. It can ask for x equals f of y. All 4 of those mean inverse. Inverse means inverse. F negative 1 means inverse. X equals f of y means inverse. Reflection in the line y equals x means inverse. Why is there 4 ways? I don't know. But there are, and all of them mean inverse. Okay? And when I tell you, people get stuck on writing the equation of an inverse, but you shouldn't get stuck on it. You should immediately think x, y split, x, y split, right? So your very first step to writing the equation is switch the x's and y's, right? So instead of having y equals x squared plus 1, we're going to have x equals y squared plus 1. That's actually the equation of the inverse. Awfully hard to draw, unless you do the t-table. Can't put it in your calculator, right? But that is technically the equation of the inverse. The catch, though, is that you'll have probably a multiple choice that's in y equals, and this one isn't in y equals yet. So we have a few steps to go until we're done. Correct? So what do we move first? Remember reverse BEDMAS. So we always have to do addition and subtraction first. Multiplication, division next. Exponents, brackets, right? We do reverse BEDMAS. So what do? Do I square root first or move the plus 1? Move the 1, right? I have to do all my additions and subtractions first, unless they're locked in a bracket, because brackets are always done last. We're doing reverse BEDMAS when we solve. So subtract 1. So we get x minus 1 equals y squared. LC. And then I'm going to do this physically moving square root symbol. And when I do that, what do I always have to do? Add a plus or minus. This would go on my little sheet that I would have at the beginning of this unit that would say, remember to put plus or minus signs when I take the square root of a function. So I would make myself a sheet, and you guys can start it on the next unit if you want. I would always do this. When a prof is going, they're like, remember this. I always had a side sheet that put all my little remembering things, and it went at the very front of each unit. Because those are the things I know I'm going to forget. And when your teacher says, remember this, you're going to forget it, they know this because they've taught it numerous times, and everyone screws up in that same spot. Just like in binomial theorem, like when I said it's like 3x squared to the 4, I tell you you're not going to remember to distribute the 4 to the 3. You do it to the x, but you forget to put it in the coefficient. Same thing. I put on a little side note. All right, plus or minus sign. On the test, there will always be at least a quarter of you not putting plus or minus signs, and I'm sad. Okay? So it's y equals plus or minus the square root of x minus 1. How the heck do you put a plus or minus sign in your calculator? Trick question. You don't. There isn't one. You have to put it in as 2 separate equations. So in y1, go through this. In y1, you're going to put square root x minus 1. And then y2, you're going to put negative square root x minus 1. And in y3, put an x squared plus 1. Put all of them in. So you're putting in the inverse ones. Square root x minus 1, y1, y2, negative, square root x minus 1, y3, x squared plus 1. And then look. You know what? Put in 4. Put in y equals x. That's your identity line. So in y4, put in just y equals an x. So 1 was just square root x minus 1. 2 was negative square root x minus 1. So you have both of the things. 3 was just the original, x squared plus 1. And then 4, I wanted you to put the identity line, so y equals x. Now where the identity line happens should be where the invariant points happen, right? So it should be where the graphs are crossing. X squared plus 1. Just x. This takes so long to load, I thought I'd run out of time. So in y equals 1, and the reason why I love pulling my calculator up, because the moment I pull it up, people stop using theirs, and that is not a good thing, so I wait till you actually try it yourself. You're like, ah, she's doing it, I don't have to. But then on a test, I don't do it for you, so you have to. Okay, I press down. Negative square root x minus 1. That's just your reciprocal, or your inverse. And then we have x squared plus 1. That's your original. And then I said put in the identity line. How many invariant points are on this graph? None. The whole graph occurs with no like 1, 1, 2, 2, 3, 3, 4, 4, right? So could we sketch this? Do we even actually have to sketch the sideways inverse one? Or could we just sketch our original and flip-flop all the points and resketch it? Yeah, we can absolutely do that, right? You actually don't need to graph the inverse from your calculator or anything. You just need your original, and then you do your mapping. Your mapping is xy becomes yx, right? So just take every point and flip it, redraw it, okay? Now, wherein lies the problem on this? If I go and draw a horizontal line across this black one here, we got problems, correct? Horizontal line will not pass. We agree? So what do I need to actually find in order to restrict the domain of the original? The x of the vertex. Find your minimum. So go second trace minimum on your calculator. Second trace minimum. Because I'm doing it on this original, because I have to do the restriction of the original. Arrow up till you plop onto that graph, just so you know. You have to get onto the graph. You might be on too many of them. If it's overwhelming, take out everything but the one graph. But it says left bound, so I need to be on the left bound of the minimum. Right bound, so I need to be on the right bound of the minimum. And then enter. What's this e to the negative 7 just mean, guys? We went over this. 0. So it's at 0 and 1. Do you agree? Our vertex is at 0 and 1. It's literally like this. So this is 0, 1. Domain is only accountable to the what? The x or the y? The x. So many people will tell me x is greater than or equal to 1 and x is less than or equal to 1. Does the 1 even matter for domain? No. What is this graph being cut in half at? X equals 0. We agree? So the domain, if I restrict the original domain, it would be x such that x is either greater than or equal to 0, XER, or you'll never state both, you'll pick one. X such that x is greater than or equal to 0, or less than or equal to 0, sorry. And then you keep one of the arms, and then it'll ask you to draw the inverse after you've restricted the domain, so you're not going to write both arms again. Now, Ryder asked this yesterday, and he was totally correct. Can I pick something that's not just 0? Yep. I could just have a portion of this arm. I just need to make sure that I don't have both arms. But I could have a portion of one of the arms, correct? So, for example, I could just keep this portion. It's still pass a horizontal line test, wouldn't it? So I could say, instead of just 0, I could say x such that x is greater than or equal to what? What is the x in this one? It's a 2, right? It's happening at 2. 2. So the only time this happens, where you pick something that isn't 0, or the vertex x, is if it's a multiple choice, because they can pick something that doesn't just happen at vertex. If it's me, and it's a written response, I find the x of the vertex, and I say greater than or equal to it, or less than or equal to it. I pick one, and then I just redraw that. Does that make sense? Hopefully. Makes sense. So your homework for inverses is this. When is your hand-in due? Thursday. So 3, it's just telling me if the original is a function, then if the inverse is a function. So you're not doing any work. You're literally just doing your test. Do not redraw these graphs. You're wasting your time. Just horizontal, vertical, horizontal, vertical. You literally don't need to do more than this. 6 is a matching. It's making you determine the equation of an inverse. 6 I really like because honestly people can't find equation of inverses because they get literally stuck on the first step, swapping the x's and y's. They just don't do that, and then they sit and stare at it and go, I have no idea how to do that. If you swap the x and y, most people can find the equation of an inverse, right? Same step on that step. Equation of inverse, swap x, y. Again, I put that on my little sheet. Step 1. Solve the equation of an inverse. Swap x and y.